Hello! Welcome back to Integra Friends. On this lesson, we will be teaching you how to calculate the area between curves using integrals. We will be giving you definitions, tips, and examples in order to understand better the subjects.
According to Merriam-Webster Dictionary, the area is the number of unit squares in measure to the surface. Therefore, the area between the curve will be the number of unit squares equal in measure to the surface between two functions.
But how can we solve this? We're going to give you the next formulas in order to do it. So, the first formula is going to be used if the graph is in respect to the x-axis. On this one, we will need to subtract the upper function from the lower function. And we will be using the limits of integration that are obtained once both functions are equalized. Remember that a needs to be smaller than b. Then, the next formula will be used if the graph is in respect to the y-axis. In this one, we will need to subtract the right function from the left function, meaning the one of the positive side from the one of the negative side. Also remember that c needs to be smaller than d, which are the limits of integration.
First, in almost all of these problems, a graph is pretty much required, because the bounding region, which will give the limits of integration, is difficult to determine without a graph.
Also, it can be difficult to determine which of the functions is the upper function and which is the lower function without a graph.
Finally, unlike the area under a curve, the area between two curves will always be positive. If we get a negative number or a zero, we can be sure that we made a mistake somewhere, and we will need to go back and find it.
First, we sketch the graph of both functions. We shade the area that needs to be calculated. Then we subtract the linear that is the upper function from the parabola that is the lower function, and mark the limits of integration, which are from -1 to 2. We substituted the values and obtained 9/2 as an answer.
Now, we will make the next example, one that will be answering in collaborative work. First, we needed to calculate the roots of both functions in order to graph them. From the first one, we obtained that 0 and 3 were the roots. From the second one, we obtained that 1.85 minus 1.35 and 0 were the roots. Then, we sketched the graph of both functions, and we shaded the area that is going to be calculated. Then, in order to find where both functions meet, we will need to equalize both of them in order to obtain the roots, which are going to be the limits of our integration. This one will allow us to know if we need to divide the integration or if we can just make it directly. And also, they are going to be used once we subtract the upper function from the lower function. We obtain 0, 2, and -2. As it can be seen, we will need to integrate from -2 to 0 and from 0 to 2. First, we will integrate from -2 to 0. Here, we will need to subtract the cubic function from the parabola. Now, we will integrate from 0 to 2. Here, we will need to subtract the parabola from the cubic function, because the parabola is the lower function and the cubic function is the upper function. We cancel terms and we continue with integration, simplifying terms. It is very important to note that both integrals need to be added, they can never be subtracted. Once that we establish them, we continue integrating. We substituted the values using a calculator, so we skip that step. Finally, the area between the curves is 16 unit squares. Thanks for watching.